Young's double slit experiment, made and presented by me, Rovi Libago. So, introducing the physicist of the day, Thomas Young, dubbed the last man who knew everything, which I think is one of the coolest nicknames ever awarded to someone. Taking a quick look at his life story, he was born in Milverton in southwest England in 1773. He wasn't actually a physicist per se, he was a physician, a doctor. He studied medicine at 3 different places, and his main interest was sense perception. He was also incredibly interested in the eye and human language, which ultimately gave him an edge when studying and understanding light and sound. Looking at some of Young's notable life events and accomplishments, we start in 1792, where he started studying medicine. In 1794, he was elected into the Royal Society, then 5 years later set up his practice in London. In 1801, Young was the first doctor to describe astigmatism, prompting him to switch focus to studying light, and in the same year we get the double slit experiment. In 1807, he created Young's modulus, and in 1814, he helped translate and decipher the ancient Egyptian hieroglyphics in the Rosetta Stone. Okay, so back then, there were 2 prominent theories for the nature of light, one from Christian Huygens and the other from Isaac Newton. Both sought out to answer the question, is light particles or waves? These two had very opposing ideas, with Christian Huygens believing light moved in waves, and Newton believed light moved in particles. It's very intentional that I made Newton's picture larger than Huygens, since ultimately it was his theory that the vast majority of physicists accepted just because of his stature. So in Newton's light theory, corpuscles, it was believed that light behaved in particles. So hypothetically, if we were to do the same experiment and shoot a laser through 2 slits, naturally it would simply take the shape of those 2 holes as shown on the wall. But this theory was faulty and wasn't able to answer nor explain a multitude of concepts about light, such as why at different interfaces some light reflected and some refracted, why different colors of light refracted at different degrees. Since he believed in particles, Newton also thought that different colors of light were from the size of the particle and could not validate it through experiments. His theory also couldn't explain diffraction. This takes us to May of 1801 with Young's double slit experiment. Even back then, sound was known as a wave. And like I said earlier, since he studied light and sound, he thought, hey, what if light was a wave too? To set it up, you need a light source that emits a single wave, such as a laser. 2 slits, narrow, with only a small distance between them, placed in front of the laser, and finally a screen or wall placed at the back to observe the light pattern. What was observed was 1. Diffraction. Instead of simply 2 light strips on the screen, there were a bunch of horizontal bars of light. But more importantly, it showed a pattern of light and dark strips that were brightest in the middle and progressively got dimmer towards the edges, which is explained by 2. Interference. The brightness of the strips of light can be explained through constructive and destructive interference. Constructive interference appears when the crests of one are paired with the crest of another, or one trough with another trough, both adding to create a brighter light. The areas of darkness are explained through destructive interference, when a crest is cancelled by a trough, or vice versa. It creates the pattern shown at the bottom. If the waves differ by half a wavelength distance, that causes the destructive interference. However, if they differ by a whole wavelength, they are still in phase with each other, and it ends up being constructive. This experiment is vital for more discoveries in the science and physics world. 1. It lays foundations for quantum mechanics, the theory of the behavior of matter and light on an atomic level. 2. It sets up the fundamental new discovery of the wave-particle duality by showing that light wasn't either a wave or a particle, but rather something that contained both qualities. More on the wave-particle duality. In modern takes of the experiment, it shows the duality in action. When done like the original, it shows the wave pattern on the screen. However, when physicists tried to observe it thoroughly through machines and measure it, the photons began to act like particles and simply chose a slit and showed 2 bars. Even till this day, with all the technology we have, the results of the experiment and the nature of particles are still not fully understood.